Good day, my name is Babatunde Batayo. Today I'm going to be answering the business question as to what the correlation is between several meteorological factors that I will show and how they combine to cause forest fires. The key reason why I'm doing this is to be able to create in future predictive analysis and predict when there's likely to be a forest fire based on the meteorological factors affecting the particular area at a point in time. For my task today, I have chosen to obtain a data set from the UCI Machine Learning repository, which is Center for Machine Learning and Intelligence Services. The data set that I have is for the forest data set obtained from Montesinho Park in Portugal in the year 2007. And I have obtained this and I've exported this to my Excel, which I'm going to show you uh, right now. Just give me a second. All right, so what you see is the data that was obtained. It's over 500 rows deep. I have about 13 factors. The key components that you need to, metrics that you need to notice is the FFMC, DMC, DC, which stand for the fine fuel moisture code. The DMC is the deep moist convection. The DC is direct current. And FFMC really is the moisture content of litter and other cured fine foils that are necessary to create these conditions that cause fires. Deep moist convection causes the cloud or atmospheric conditions that are likely to create lightning and thunder that ignite this litter. This is just direct current, which is created by static electricity, and relative humidity has also been defined here because the higher your humidity, the less likely there is to be a forest fire. Uh, so these are the data that I've obtained with my pivot table. I've been able to clean the data to represent this as such. Uh, we see here for the very months of the year that the months that have most activity is September and October. We have a very high FFMC and DMC for this month. And if we take a look and see this affected area, we see that for those particular months as well, we have the highest. The count of the month is unnecessary, so I'm just going to remove that from my fields there, right? And having done that, I have already gone ahead to create some sort of visualization. For the sake of time, I'm just going to go directly to that. And what we see here is a chart showing you how these different factors uh, have created these fires and the area that has been affected. So take a look uh, at the sum of the areas, which is key. Uh, we can see for the fine foil moisture code, we see that the months of August and September, the months of September and October, I beg your pardon, have the highest value. And these are the months that we had the most fires, as you can see here. Some of areas affected in September and some of areas affected in August. So basically, our findings have been that uh, the higher the fine foil moisture code, the higher the temperatures. So we have the highest temperatures for those 2 months that are shown, and we have seen that that's when we've had the most areas affected by the forest fires, which is some of areas affected here. We had the highest in those 2 months combined. So this will be important in terms of creating a predictive analysis to see which factors these factors how they cause these fires, and this will help prevent loss of life as well as property obviously that can be relocated. Once using our meteorological instruments, we're able to determine that the conditions rather that create these fires are prevalent or are going to happen pretty soon. Thank you. That's my submission for today. Uh, Looking forward to working more on this to see what else I can figure out. Thank you.